the fourth lecture on matrices, and it's a bit more general properties of multiplication. So it basically goes through what you have to do to multiply matrices. It wasn't a lot actually. Most of it was just yabbing on about proofs and stuff. So we have two matrices. We have A, and B is a column vector. You can see here, A, so we've got the columns here, we've only written them in, so A1 all the way up to AN, and B1 all the way down to BN. Remember, they have to be the same number of columns in this one as the same number of rows in this one. So when multiplying them, we simply times the first row by the first value, the second row by the second value, and so on, until we times the last row, the last column, sorry, by the last row value there. And that's all the way down. So you basically, if you want to think of it, you're grabbing this and turning it and putting it above this vector and multiplying down and adding them all up. Yep. So I've done a representation in the next one. So this, I don't know if you can read this very well. I did this in Maple, and we have Maple code here. If you're wondering how to multiply matrices in Maple, it is actually very useful. So I've got a matrix A as A, B, C, X, Y, Z, and a B as E, F, G. So I've multiplied A, B, just like in the previous example, we had a big one and a column vector, and we've multiplied them. So that gives us AE plus BF plus CG on the top, because we've multiplied it all, and XE plus YF plus ZG. Now, as you can see, that's kind of what happened. We've grabbed this, we've turned it, we've multiplied the top one and times them all together, we've multiplied each of the top ones and added them together, and then we've done the same again. We've moved it and we've multiplied all the bottom ones and added them together, which is just what we've got. Now, there's a little bit trickier one here. We have A is the same, A, B, C, X, Y, Z, but B this time is E, F, G, H, I, J. And multiplying these, it's just the same, except we've got to do it twice. So we grab the first row, the first column, sorry, E, G, I, and we move it, and we multiply the top one, the top row, and add them all up, which we have here. And we do the same to the bottom, and add them all up, which we have here. Now, they haven't put commas in on Maple, but it is split up here, it is not together. And then we do the same with the second column here. We get the second column, we move it, and we times the first ones and add them together. And we do the same with the bottom row as well. Times them and add them together. So if you can't read it, I'll just say it out loud. We have AE plus BG plus CI, XE plus YG plus ZI, and over here AF plus BH plus CJ, and XF plus YH plus ZJ. Now, he didn't actually finish proving it, in my opinion, so I hope my visual representation of grab it and move it makes sense. And we're starting inverses soon, and that was all there was. It's a very quick lecture.